Do you struggle with adding and subtracting fractions? Stick with me for the next 5 minutes while I take you through a clear and easy way to complete these questions. Right, let's start with a diagram. If we had 2/8 and we were trying to add it to 3/8. If we had 2/8, that would be 2 out of 8 shaded in, and 3/8, 3 out of 8 shaded in. If we were just to simply combine those together, in total we would have 5/8. Now, this demonstrates one of the most important principles when we're adding and subtracting fractions. We do not add the denominator, only the numerator. 2 plus 3 is 5, but the 8 remains constant. That's because we still have the sections in 8s. They haven't got bigger, they haven't got smaller, they're still 8s. We just have more of them. If we move on to a question where the denominator is no longer the same, it begins to get a little trickier. So this time we're going to have 1/4 added to 3/8. Now, 1/4 is 1 out of 4 shaded in, and 3/8 is 3 out of 8 shaded in. Adding those together. Now this time it's not just a simple case of combining those pieces because the pieces are different sizes. If we were to split the quarter into 8s, oh there we go, then we can see that we've got 2/8 there, and 2/8 is the same as 1/4. So 2/8, we're still adding it to our 3/8, and now we can easily combine them to get our 5/8. So, key point here is that you've got to have the same denominator in order to add those fractions together. So let's look at some questions where we have to convert the denominator so that they are the same and the process of doing so. A fifth plus a fifth. Now, this question on a GCSE foundation paper was worth 1 mark, and it was simply testing that rather than add the numerator and the denominator, you knew that it was 2/5. So they were just checking that you were not going to add the denominator, the bottom number as well. It was 2/5. A fifth plus 2/10 is next, and now we can start to see that our denominator is no longer the same. So how do we work out what the denominator is? We need to make equivalent fractions. That means fractions that are equal to a fifth and 2/10, but that have the same number. So the 5 times table is 5, 10, and the 10 times table starts with 10, and we can identify that 10 has appeared first. 10 is our lowest common multiple. The first fraction has been doubled because 5 has been times by 2, 1 needs timesing by 2. Now the fraction is actually equal, it's exactly the same, just the numbers have both doubled, making it equivalent. And in the second fraction, the 10 has not changed at all. It's still 10, just been multiplied by 1. So do the same to the numerator. Adding them together gives us 4/10 in total. That can be simplified. They can both be divided by 2 to give us 2/5 as a final answer. And you can see now that we've moved on to 2 marks. And the reason that's 2 marks is because you had to do that conversion first. Right, moving on to a question where the denominator is slightly trickier. So 8 and 6 this time. We're trying to think in the 8 and the 6 times table, what is the first number that appears in both? So 8 times table, 6 times table, 8, 16, 24, 32, 40. And the 6 times table, 6, 12, 18, 24, 30. Now have a look what number has appeared in both already, and it is the number 24. So that's what we're going to use as our common denominator. And in the first question, the 8 has been multiplied by 3. 3 times 3 is 9. The second fraction, the 6 has been multiplied by 4, and 5 times 4 is 20. So you keep the fraction equivalent, equal, by multiplying them both by the same. 9/24 plus 20/24 in total is going to give us 29/24. But you don't want to be leaving that as your answer because it's an improper fraction. The number on top is greater than the number on the bottom. Ask yourself how many 24s go into 29. 1 24 goes into 29, and we have 5 24ths left over. So 1 and 5 24ths. Right, moving on to a subtraction. Now it's not much different. We still have to have the common denominator. The only difference this time is we're subtracting the numbers rather than adding them. So 5 and 6, what is our lowest common multiple of 5 and 6? 5 times table, 5, 10, 15, 20, 25, 30. And our 6 times table, 6, 12, 18, 24, 30. And 30 is the number that appears first in both. It is our lowest common multiple. So write both of your fractions over 30, and it's now a case of working out what has each one been multiplied by to get to that 30, to keep them equivalent. 5 has been times by 6, 4 times 6 is 24, 6 has been times by 5, and 1 times 5 is 5. So the calculation becomes 24 over 30, subtract 5 30ths, giving us 19 30ths as your final answer. Once again, another 2-marker question because of that conversion that you have to make. Moving on then to mixed numbers. Now, first of all, let's be clear what a mixed number is. If I had the number 2 and a third, it is mixed. And the reason it's mixed is because it contains an integer, which is a whole number, as well as that fraction. So the integer would be 2, the fraction would be a third. In combining them, they're mixed. Now, you need to convert them into an improper fraction before you move on to answer these questions. The numerator is bigger than the denominator. 2 and a third, how do we convert them? Keep the bottom number, keep the denominator the same. It's still going to be in thirds. That's really important. Now, what is 2 in terms of thirds? Well, 1 is 3/3. We need another one, that's 3/3. And then we also have this third here at the end. So 1, 2 and a third. Now in total, how many thirds do we have? We have 3, 6, 7. A quick way of doing that is to do 2 times by 3, add the 1 on the top. So before we do any of these questions, we have to convert them into improper fractions. You don't actually have to, and you may have been taught that it's okay to do it as a mixed number. But as we progress forward onto the division and the multiplication of mixed numbers, you have to convert them. So I'm sticking with the 1 rule for all, and we're going to convert them into an improper fraction. So 1 and a fifth, keep the denominator the same. 1 times 5 is 5, add your 1 on the top is 6. So we're doing 6/5 and we're subtracting 3/10. 6/5, once again, denominators are not the same. We need to convert them so they have the same denominator. So your 5 times table and your 10 times table, you will see that it's the 10 that appears first in both. That's going to be our lowest common multiple, our denominator. Okay, what's happened to the 5 to get to 10? It's been doubled, so do exactly the same to the numerator to keep it equivalent. 12, 10 has been times by 1, 3 times 1 is 3. Subtracting them this time, 12/10 subtract 3/10 gives us 9/10. And that's how you get your 2 marks for that question. Key take-home messages when you're adding and subtracting fractions is to make sure that denominator is the same. I'll see you in the next video.